This is Geometry, Unit 5. This is our second day in Unit 5. We're going to talk about the properties of rhombuses, rectangles, and squares. It can get a little confusing. From kindergarten, we've known about a square. We know that a square has 4 equal sides. And the angles are all equal. A square has 4 equal sides and 4 equal angles. That's a little bit different than a rectangle. A rectangle has 4 equal angles, 4 angles that are all 90 degrees. A rectangle, the only requirement is that it has 4 congruent angles. We don't know about the sides. So that actually means that a square is a type of rectangle. A square is a rectangle. A square has 4 right angles. So a square is a rectangle. A rectangle might have 4 equal sides, but it doesn't have to have 4 equal sides. What it does have to have, a rectangle is a parallelogram, so it has opposite sides congruent. That's for sure. And it has another pair that are congruent. That is for sure. It's possible that they're all the same. And when a rectangle has all equal sides, we would just call it a square. But a square is a type of rectangle. A square is always a rectangle. A rectangle is only sometimes a square. Now we'll talk about a rhombus. A rhombus has all equal sides. So if we take our sticks and we put them all together, we can create a rhombus. This rhombus might have angles, interior angles that are not 90 degrees, or it's possible that they could be pretty darn close to 90 degrees. So a rhombus has 4 equal sides, just like a square does. But a rhombus does not have to have 90-degree angles. A rhombus has to have 4 equal sides. But a rhombus might have 4 equal angles. We know for sure that a rhombus is going to have opposite angles congruent because it's a parallelogram. All of these are parallelograms. Consecutive angles are supplementary. So it holds all the properties of a parallelogram. So a square is always a rhombus, but a rhombus is sometimes a square. You might have your shape of a rhombus. You might have it look like a square, maybe, but you don't have to. I still have a rhombus. But this rhombus might be a square. It is sometimes a square, but not always. So let's come on down here to example number 1. We're going to look at a rhombus. I'll draw a rhombus for us. Just approximating the best drawing we can do. We're trying to make all the sides the same. So we'll put tick marks on those to ensure that those sides are supposed to be the same. Now the name of this rhombus is RSTV. You can put the R in any corner that you want. Your choice. Doesn't matter. I will put my R right here. Now, you need to put the S on a corner, on a vertex that is consecutive or adjacent to that one. You cannot place it across. It has to go in consecutive order when you name it. So R, S, T, V. You could have gone the other way, R, S, T, and V. That would have been fine. But you cannot crisscross the shape. So they want to know about S and V. Is angle S congruent to angle V? Does that always happen? Or does that only sometimes happen? Well, let's go ahead and take a look at our little figure. We have opposite angles. Right now they're both small. And as I adjust it, can we ever get it where the top and the bottom angle, one is small and one is big? And the answer is no. They always stay exactly the same. Always the same. It's a parallelogram, right? If a quadrilateral is a parallelogram, then opposite angles are congruent. So this is going to be always. It's always going to be congruent. If you have a parallelogram, well, this is a rhombus. Yes, a rhombus is a parallelogram. Let's take a look at T and V. T and V, they're consecutive angles. If a quadrilateral, we'll just call it quad, if a quad is a rhombus, then consecutive angles are sometimes congruent. Take a look at our shape. Consecutive angles are not congruent here. We've got a small one, we've got a big one. But if we adjust that and make the angles different, it is possible we get to a spot where they're exactly the same. So sometimes it can be there, but not always. It doesn't have to be there. A rhombus doesn't have to have consecutive angles congruent. So this is sometimes. All right, we flip it over. Let's take a look on the flip side. Here we have a shape. The one thing that we know for sure is our four sides are all congruent. That's what we notice. The four sides are congruent. So I'm going to have the same color here in my figure. Classify the special quadrilateral. Okay? Well, there's a couple different things that we can say this is. We could say this is a geometric shape, Mr. Weber. And you wouldn't be wrong. Yes, it's a geometric shape. Can you be more specific? This is a polygon. Okay, that's true. This is definitely a polygon. It is made up of segments. It has nothing to do like with curvy sides, like a circle. It's not three-dimensional like a cube. It's a polygon. Geometric shape could be a cube, could be a three-dimensional shape. Could be a circle or a combination. But a polygon has to be two-dimensionals. It's got to be made up of segments. But can we be more specific? This is a quadrilateral. It's a parallelogram with four sides. Well, that's true. You can probably be more specific than that. This is actually a parallelogram. We probably don't have all the facts to prove that at the given second. We're going to learn that as we keep moving on, but if you have opposite sides congruent, two sets of opposite sides congruent, then you have a parallelogram. You can't make this shape with opposite sides being congruent, especially all of them being the same. That's not a parallelogram. It has to be a parallelogram. Well, is this a special type of parallelogram? This is a parallelogram that has all four sides congruent. If a parallelogram has four congruent sides, then it is a rhombus. Now, some of you might say, well, that's not true, Mr. Weber. It might be a square. You could have four equal sides with four equal angles. Well, true, but a square is a type of rhombus. Okay? We know this is not a square because one of the angles is 127. So we know this is not a square. We know that opposite angles are congruent. So this would be 127 if we cared to know that. Or consecutive angles are going to be supplementary. So we know that that's going to be 53. And opposite angles are congruent. So if we needed to know those other angles, we now know for sure they're not 90, 90, 90. This is not a square. This is just a rhombus. That's the best name. That's full credit if you say rhombus. All these other names are not specific enough. All right, let's come on down here to our last one. If we have a square, now think about what a square is. A square has 90-degree corners, and it has sides that are all exactly the same. So our sides are exactly the same. That's a rhombus. The angles are all exactly the same, or they're all right angles. So it's a rectangle. So this is a rhombus rectangle, which we would typically call a square. Now, if we were going to name this square CDEF, you can put the C anywhere you want. It doesn't matter where you put the C. I'll put my C right here. Now, to put the D, you can put the D on either direction around it, but you cannot put the D, the second letter, across from it. It's got to go around in a consecutive order. I typically go clockwise when I do this. So C, D, E, F. It doesn't matter where you start the C. If you start the C in this corner, the E is still across from it. Or if you start it in that corner, it's still across from it. Doesn't matter where you start it from. So what we want to figure out, is it always or sometimes true that segment CD, that one, is it congruent to DE? Sometimes, always, or heck, we could even say never. If this is a square, do those two sides have to be congruent or might be congruent? Always or sometimes?
Always.
Of course. If a quadrilateral is a square, then it has 4 congruent sides, so they're going to be congruent. All the sides are congruent. And it also has 4 congruent angles. We're not talking about angles here specifically, but we are talking about 4 congruent sides. So it is going to be always.